Welcome to section 2.3, writing equations of lines. So here's a question. What does it mean to write an equation of a line? And is there only one possible equation for a line? Well, first off, what does it mean to write the equation of a line? Basically, it means to create an equation. So to create an equation from given information that describes a specific line. Okay, so that's basically what happens. You'll be given some information and then you'll manipulate that information into the equation of a line. Now, is there only one possible equation for a line? And the answer is no. There are numerous different possibilities. However, sometimes you need to answer in a specific form. More often than not, the specific form would be y equals mx plus b form. Usually that's the one that if they're going to be specific on what they want the equation to look like, that's what you would need to answer as. So example 1. Write an equation for the line that has a slope of m equals 2/3 and a y-intercept of 0, -6. Okay, so as usual, one of the huge key things, my directions. Write an equation for the line. So I know I need to have an equation. What information am I given? I am told the slope and the y-intercept. So I'm going to think. Do I know a generic equation for a line? I do. Right here, I just mentioned it earlier. Y equals mx plus b. This is, once again, if you read it, slope-intercept, which is why it's called slope-intercept. So we have the equation of a line, a slope-intercept form. And I'm given a slope and an intercept. So what do you know? I can use that format. So I'll go ahead and write down the generic equation. Please always write down the generic one before you fill it out. And then I know that my slope is 2/3. So I can replace that with 2/3. And my intercept is -6. Replace that with a -6. And there we go. I have turned the generic form of an equation of a line into a specific equation for my line using the given information. Hopefully not too bad. Okay, so this is called the slope-intercept form of a line. But there's one other form that is actually more generic. So if you'll notice, this needs a slope and a very specific point. 1 point. And remember, lines have infinitely many points on them. So this is super restrictive. It says you need the y-intercept. Not any other line, the y-intercept. So we have another equation we can use that is really generic. It doesn't matter which point you use, you can use it. So you're not restricted as much. And this one is called point-slope form for a line. And this is what it looks like. Y minus y sub 1 equals m times x minus x sub 1. Where you need your slope and 1 point to fill it out. Okay, so this one is even easier to use because we don't need specifically the y-intercept. We can use any point that we're given. Alright, so more than likely, if you're told to write the equation of a line on a problem, this equation should usually come to mind because a lot of the times you're not given the y-intercept. Let's see. Example 2. Write an equation for the line that passes through the points 0, -3, and 6, 2. Answer in slope-intercept form. Okay, I know we're writing the equation of a line, so my brain thinks of 2 equations that I know work for writing the equation of a line. The question is, which one should I use? Well, let's take a look at what we have. So we have only 2 points. Now here's the question. To fill out this equation, I need the slope and a y-intercept. Do I have a slope? No, I'm not given the slope. Do I have the y-intercept? No, I'm not given the y-intercept. So you know what? This is looking like a bad choice. How about this one? What do I need to fill that out? I need a slope. Well, I don't have the slope. Okay, it's a little frustrating. But I just need any point. And I do have any point. I have 2. So the question is, how could I find the slope? Well, let's remember, finding slope we can use this equation if I have 2 points. And I am given 2 points. So here's my plan of attack. First, we'll create the slope. Then we'll use this, plug our slope in, and then pick one of these random points to plug in as well. Okay, let me go ahead and erase my scratch work here. We have our plan down. Alright, so we're going to write down the equation we want to use, which is going to be point-slope form. Once again, why did I pick that? Because my given information can fill this out better. So let's go ahead and find slope. So m is going to equal y1 minus y2 all over x1 minus x2. x1, y1, x2, y2. So that's going to equal negative 3 minus 2 divided by 0 minus 6. Negative 3 minus 2 is negative 5. 0 minus 6 is going to be negative 6. So simplifying the negative divided by negative, that's a positive. So m equals 5 over 6. And there's my slope. So I can go ahead, plug that in. My slope is 5 over 6. Now I need to plug in a point. Which one do I choose? It's really up to you. Either one works because they're both from your line. I like to pick the one that has the smallest numbers, so I'll go with 0, 3. So my y1 is that negative 3, remember your parentheses, and my x1 is a 0. So let's plug these in a little better. Okay, and so usually you could kind of finish there, but I'm told to answer in slope-intercept form, which if you recall is y equals mx plus b, and that is not currently solved correctly. So let's go ahead and simplify. The double negative will become a y plus 3 equals 5 over 6 times x. Well, we got to solve for y. So let's go ahead, subtract 3 from both sides. And we have that y equals 5 over 6x minus 3. And voila, we have our answer in perfect slope-intercept form, where we have our slope here in yellow and our y-intercept here in red. Alright, okay, let's see, moving along. Write the equation of a line that passes through the points 4, 3 and 4, 6. Okay, so once again, I think about my two equations. My slope-intercept or my point-slope. I am not given the intercept, so I'm not going to use this one. There are ways to use it. Some teachers do teach a method for that, and if you like that method, you can go ahead and use that. I usually default to using this equation. And to use that, first we need to find the slope. So let's go ahead and set up to find the slope. Alright, so y minus y sub 1 equals m times x minus x sub 1. So finding m equals y sub 1 minus y sub 2 over x sub 1 minus x sub 2. I'll go ahead and label these my sub 1s and these my sub 2s. So I got 3 minus negative 6 divided by 4 minus 4. So m equals 3 plus 6 because we have that double negative there. So 3 plus 6 is 9 over 4 minus 4 is, 0. Oh gosh, we have a 0 in our fraction. This is a number over 0, which means my slope is undefined. Ooh, that should ring a bell. Which line has a slope that's undefined? That is the line, a vertical line. So a vertical line has an undefined slope, which means our equation is a vertical line. So that is going to be x equals whatever our x value is, which is 4. So our equation is x equals 4, and we didn't even have to use that. Okay, so if you ever end up with a slope that's undefined, you know it's x equals your x value. Or if you end up with a slope of 0, you know that's going to be a horizontal line. So you would have y equals some number k if you had the slope equal to 0. Since our slope was undefined, that means we had a vertical line. So we had x equals 4. Once again, where did that 4 come from? That is the x value of our points. Alright, let's take a look at another example. Write the equation of a line that passes through 0, -1 and is perpendicular to the line x equals 4. Ooh, look at that. We brought in some fancy words here. Perpendicular. What does that mean? Perpendicular creates that right angle. That means the slopes are opposite reciprocals of each other. Okay, let's see. We want to write the equation of a line. In my information, what am I given? 0, -1. Is that... Hey, that's the y-intercept. Ooh, I'm given a y-intercept. So, I can go ahead and use this equation here, y equals mx plus b, because I'm given the y-intercept. If I wasn't, I would have to use this generic equation. Once again, though, some people do know how to use this a little differently, but I don't go over that method in this course. If you're interested, feel free to stop by my office hour. Okay, so we're using the slope-intercept form because we're given the y-intercept. Let's go ahead and plug in that y-intercept. Should be -1. And now we need the slope. Well, we're not given the slope, but we're told that my line is perpendicular to this one. Well, that is x equals 4. Hey, that is a vertical line, which means its slope is undefined. Or, that's a number over 0, right? So I have a vertical line, and my line is perpendicular to that vertical line, which means my line in blue should actually be a horizontal line, because it's perpendicular to that vertical line. And what are the slopes of horizontal lines? The slopes are always 0, so my slope is m equals 0, because my line is perpendicular to a vertical line. Okay, so my slope is 0. I end up with y equals 0 times x minus 1. Well, I can simplify that. That's just y equals -1. And does that make sense? Well, yes, this is the equation of a horizontal line, because we only have y in the equation. And that makes sense because I knew my line was supposed to be horizontal. Alright, moving on. Example 5. It costs $10 for a basic car wash at the Enchanted Lakes Car Wash in Kailua. Whenever Keiko gets her car washed, she also buys gas for her car, which is $4 a gallon. So how much would it cost her if she bought 1, 2, or 3 gallons of gas and a car wash? Alright, let's set this up. So we know we want a certain number of gallons, and then we want to find out the price, right? Okay, so we want 1 gallon, 2 gallons, or 3 gallons. So if she has 1 gallon, well, we know it's going to be $4 times the number of gallons she has, which is 1, right? But she also buys a car wash for $10, so that's going to be plus $10. So that'll end up being $14 for 1 gallon. And then, let's say she wanted 2 gallons. Well, that would be the $4, right? Times 2 gallons, plus the $10 for the car wash, which should equal, well, 4 times 2 is 8, so $8, plus $10, that's $18 for 2 gallons. And then we have, let's see, once again, so the price is $4, but we want 3 gallons, so that'll be 4 times 3, because she pays $4 each gallon, plus the $10 for the car wash, which that should equal $12, plus the $10, so that'll be $22 for the 2 gallons. Sorry, for 3 gallons. And on, depending on the number of gallons she buys. So all you do is basically you multiply the number of gallons by 4, and then you add the $10, right, to figure out the cost. So now we want to write an equation that defines the cost for Keiko's visit. Let x stand for gallons of gas bought. Well, if you look at the pattern we had above, each time we looked at the different gallons, all we did was we multiplied 4 to that number, and then we added 10 to it. We did that every single time. The only thing that changed each time was, what? The number of gallons is what changed. So what we're told here is to let x stand for the number of gallons. So let's follow the pattern we had here. we'll do the $4, and then we'll times it by the number of gallons, which we're told is just X. And then we'll add the $10 to it. Okay, and then we'll just go ahead to create this into an equation. We'll say y equals 4x plus 10, where x is number of gallons and y is the cost. And there we have our equation. So for part C, how much would it cost her if she bought 9 gallons of gas and a car wash? Well, let's go ahead and use our equation. Why not? So we know that y equals 4 times however many gallons she has plus her car wash. Well, what are we told the number of gallons she has? She's getting 9 gallons. So let's go ahead and input that 9 plus 10. Y is going to equal 4 times 9. Let's see, what is 4 times 9? That is 36 plus 10. Then y equals 46. What does that mean? Remember, y is the cost. So it would cost her $46 to get a car wash and 9 gallons of gas. And that is it for this video. If you have any questions, please come by an office hour.